Hi, in this project we are going to find the doppelganger uh, uh, for your celebrity look alike. That means that we will take a image from a person and then we will look within a celebrity dataset to see which is the celebrity that looks alike this initial image. Okay, so in order to do that, just to explain it a little bit better, we will take an image like this one here, and we will find the celebrity that looks very similar to this original uh, image, and we will do the same for these two images. Okay, so this is the expected output that we are going to expect from our uh, uh, algorithm. Okay, so in order to do that, the first thing that we need to have is a data set for celebrities. So there are many data sets available in internet. So we are going only to use the celebrity together dataset, which is 400 megabytes in size, and it has 1,100 celebrities. But instead of working with the complete dataset, we are going to use only a mini version of that dataset where we are going to take only 5 images per celebrity. Okay, so that will allow us to reduce the dataset size to 70 megas, which is fine for this kind of exercises, is where we don't want to have the highest accuracy. Okay, so this celebrity dataset will have this structure. Okay, so we are going to create a directory called celeb mini, and then we will have a subdirectory with a naming like this one here, as you can see. And then within these subdirectories, we will have the images, the 5 images that we mentioned before. Okay, and we are going to have also a dictionary that is stored in this file here, celebmapping.mpi, and this dictionary has a key with the name of the sub directory that we were mentioning before, and we will have the name of the celebrity. Okay, so let's start. Okay, so uh, first thing to do is that we are going to import all the required libraries in Python. So we are going to work with dlib, mainly just for the face detector, just to find the face landmarks, and also we are going to use the neuronal network that is using dlib, and we will use that network just to enroll the celebrities in our model. And once that we have all the celebrities enrolled in our model, we are going to check with the test images, which is the associated celebrity model. Okay, and we are going to save part of the results of this model in a pickle object. You know that pickle is library in Python that allow us to save nearly any object in Python. So that's very convenient because that will save us to run again the model, which we will see later on that it takes a few minutes just to run. And we are going to configure matplotlib with the standard configuration that in terms of size, color map, and interpolation just to fit in within the size that we want. Okay, so first thing to do is that we download the models for the landmarks. This is the dlib, and we are going to download the model from GitHub from JVSkin, which is the developer of the dlib library, and we are going to download the 68 face landmark model. We are going also to download the recognition ResNet model. Okay, and we are going to create these objects here. Okay, the first object is the face detector that is using this dlib library. Once that we have the face detected, we are going to get the landmarks. For that, we will use the shape detector predictor uh, method, which is using this model that we just downloaded from here. I just commented out these lines, so the first time, the next time you run the notebook, you don't need to download everything again. And also we will have the face recognizer, which is this ResNet neural network, uh, and is using this model here. Okay, and we are going to download also the dataset for the celebrity with this mini version where we only have 5 images per celebrity. Okay, and we are also going to download the mapping where we have the dictionary associating the subdirectories with every celebrity, and finally we will have our test images directory, which contains uh, the two uh, images that we were seeing here at the very beginning. Okay, these two images here. Okay, so once that we have downloaded everything, let's explore the dataset. So we uh, load the mapping, and we will store that mapping in this label map variable, and we are going to explore a random image on this directory. So we are going to use listdir with within this directory here. Select a random choice and associate or get the celebrity name using this mapping here that we already said that it was contained in this directory. Okay, and then we will visualize the image. So in this particular case, well, we have some images from Max Charles, and these are the images that we have on the dataset. Okay, one important thing to consider when we are creating datasets is that the images should be as different as possible in order just to have a very good recognizing capability, because if all the images are looking similar, the neuronal network will not learn as much as possible, and hence uh, we will have a low prediction capability. So it's important that every image has very different features. So you can see here that this uh, person was very young. Here we have a different some years later, and also the illumination is rather different. You can see also here that is also quite different. Here it has also sunglasses, and you see also how different with the backgrounds are also rather different in all the images. So you see that the more diverse the images in the data set, in the data set, the better. Okay. So once that we have already explored our celebrity uh, data set, we are going to enroll all these celebrities in our model. Okay, that will be the best way then just to work with the predictor. Okay, in order to do that, we are going to define two helper functions. The first helper function is a process where we are going to use oswalk. Okay, and in oswalk we are going to explore all the files that have these extensions, PNG and GPG. Okay, and Part of the pre-process will be to load the image, okay, and then convert the image from BGR to RGB. You know that OpenCV is working with BGR, but our dlib library is working with RGB, so we need to convert that. And this helper function will be a generator, okay, that provides the NumPy array of the image and also the path. Okay. Second helper function will be the dlib face descriptor. Okay, so for that we use the two outputs of the previous function. Okay, and we are going to use a return a directory with the descriptors with corresponding to every face that we found on every image. Okay, uh, this directory, this dictionary is not strictly speaking necessary in this case because as you can see here we have only a single face per image. Okay, so but we have done this helper function uh, general enough just to cover several the possibility that we have several faces on the same image. Okay, so first thing to do is just to apply our face detector to our NumPy array image, okay, and get all the faces. Okay, then we are going to well, see how many faces we have detected, okay, in this image. And then for every face that we have detected, okay, we are going to get the feature vector. Okay, so in order to do that, first thing to do is that we get the landmarks of the face. So we use the shape predictor object that we mentioned above, and we apply the original image and also the face. The face, if you remember, in the lib contains a bounding box. So it has the rectangle that defines the where the face is within the image. Okay, and once that we have this face detected, we can get the landmarks. Okay, the landmarks are in dlib format, which is using these parts, and we are going to convert that into a conventional Python list, okay, using these tuples here, where we have the X and Y coordinates of all the landmarks, okay. And once that we have these landmarks, we are going to create the face descriptor, okay. So in order to do that, we are going to use the neuronal network model that we mentioned before, and we are going to use this method, the compute face descriptor, where we introduce two inputs, the original image and all the uh, landmarks of the face. Okay, and then uh, with this face descriptor, we are going to convert it into a list, and this is what we are going to do on here. We create a face descriptor list using this expression here, and then we convert it into an NumPy array. Okay, and we will store that in our dictionary uh, with enum corresponds to the number of faces that we have found on the image. Okay, and we will return this face descriptor dictionary. Okay, that you see here. Okay, so once that we have these two helper functions, we are in a position just to work with the celebrity directory just to do the enrollment. Okay, so for that we are going to create this uh, to define the directory where we are going to read all the images, our face descriptors that we will initialize to none, and we are going to define two dictionaries. One of them will be uh, the one that contains the subdirectory where we have uh, the images. So index will contain this subdirectory, so we can index that just with the dictionary using this file here, just to get the name of the celebrity. And index path will have the complete path to access these images here. Okay, so let's go back to where we were, and we are going to measure the performance of our uh, uh, enrollment, okay, using time. Okay, perhaps this is not the best function in NumPy. It's better just to use time it, but well, as we only want to have a rough estimation of how long does it take to enroll all the phases, that's good enough. Okay, and as this is a very long process, we want to store part of the information on here so we can get traceability. If something goes wrong, we will store some information in this descriptors CSV file that will contain uh, how many seconds we have consumed enrolling each phase, so we can have some statistics later on. Okay, and so first thing to do is that we are going to use the generator that we mentioned before with the process. So we will feed it with the directory, and this will give us the image as a NumPy array and the path. We will start measuring our time, and then we will use the second helper function with the phase descriptor that uses these two inputs from the dlib preprocess, and we will get this dictionary of phase descriptors. Okay, so then for every key in this dictionary, we are going to uh, create our phase descriptor array. Okay, and first thing to do is just to get to the descriptor, which is an array, a vertical array of 1 times 128 dimensions. So it's an array of 128 numbers that describe this image. The first time, well, we will initialize our phase descriptors to this descriptor that we got here, and for the rest of the times we will just concatenate the previous NumPy array with the new descriptor. And that's what we are doing here. Okay, and then we are going to save the label for each phase. Okay, and as we have access to the path of the image, we are going to get only the latest sub directory. So that's why we are using -2, because -1 will be the name of the image. Okay, and this is our input to our label map, that if you remember, label map has the mapping between this directory, sorry, between this directory and the name of the celebrity. Okay, uh, so index will contain such information. Okay, and we will have a direct match between the descriptor and the index by means of this enumeration that we have is initialized on here. Okay, and we are going to do the same just to store the image path. So we will save it on this dictionary on here. Okay, and we will increment a num for every descriptor that we have, and we will save that on our CSV file. Okay, and this is the output that we will get. Okay, so you can see here that uh, not always we are able to detect some phases. So in some directories we are missing the phases. Okay, so that's an important issue to take into account. And in terms of timing, It's more or less, it takes around 60 to 70 milliseconds just to enroll each phase. Okay, so once that we have completed this, that as you can see here, it takes around 600 seconds in my computer. Okay, we will save uh, the phase descriptors on this file on here, and we will save as a pickle object the index that we mentioned before, where we have the relationship between uh, the index of the descriptor and the celebrity. Okay, and also we are going to save in another file our path to the original image. Okay, these are the 700 seconds that I mentioned before that it takes to uh, enroll the dataset. Okay, so once that we have all our celebrities included in our model and stored in this descriptor file, we are going to do our testing. Okay, and for our testing, the procedure will be very similar. We are going to load the three files that we have created before with the descriptors of our celebrities, the index just to get to the name of the celebrity and also to the path of the image that corresponds to that index. Okay, in this case we are going to work with the test directory, which is on this directory here, and the algorithm will be very similar. So we are going to use this generator to get the image, the pre-processed image and the path. We are going to find the descriptor for these test images. Okay, and we are going to take the descriptor for that phase. Okay, so once that we have the descriptor, we are going to calculate the distance, the Euclidean distance between the descriptor and our phase enroll. This phase enroll, if you remember, is this uh, NumPy array where we have the descriptors of all the celebrities. So we will use this linear algebra method in NumPy array, and we will calculate the Euclidean distance with the distance between our celebrities and our descriptor. Okay, and of course this will be on axis 1. Okay, so once that we have this distance, we are going to calculate the index to the minimum distance, okay, by using the argmin method in NumPy, and that will give me the index argmin, and then I will calculate the distance corresponding to that index in the distances, in the Euclidean distance, okay? And that will give me the minimum distance that I have. So that will give me the image of the celebrity that is closer to my test image, okay? And I will access the name of the celebrity using index and the same uh, index, okay? And I will access the path of that image, celebrity image, using this function here. Okay, so once that I have that, we will find the celebrity, and again we will convert this to RGB. As we have the path to the celebrity, we will convert that to RGB format, and we will have our celebrity image NumPy array here. We will calculate the time that takes just to complete all this process here, and then we will uh, plot the images. Okay, so in the test cases, we are going to plot the name of the image, okay, and then we will plot aside the associated celebrity. Okay, so once that we run here, we can see that the test image is corresponding to Shashikant Pidwal, and the associated celebrity is Amitabh Bachchan. Okay, that you can see here that it took 81 milliseconds, and uh, it has detected one face on here. Okay, and this is the associated celebrity. And in case of Sofia Solares, which is this girl here, the associated celebrity is Selena. Okay, this is not exactly what it was expected, because if you remember from this introduction, we will expect that using this test image, we will get this image, and I don't understand why it doesn't work. Okay, because it's working well for this girl here, and it has resolved everything here, but it doesn't match this face here. Actually, I have been checking if there was something wrong with the detection of the images, so I have gone through this area here just to find uh, this directory corresponds to this celebrity here, and this image that is the input for our, or this is the expected output for this celebrity, which is uh, sorry, uh, this image is what we expected to have as a result of our algorithm. It was properly detected. Okay, so there was no error on our file during the enrollment of this celebrity face on our model. So and what I have noticed is that also the distance, let's check, uh, let's change argim to -3, and if we run here this, you see that now we have the right uh, image. Okay, this is what it was expected. So we have like a error on index for this particular image of 3. But when I check this in terms of distance, let's print the distance. Print. I'm going to check the distance argmin -3, which is the expected output, and the distance of what my model has found. And if I run this, you see that this image here, the previous image, the image that we expected to have, has a higher distance than the image that I'm showing here. Okay, so I don't know why I don't get the same result as it was expected, because obviously the distance that this image has in terms of features is smaller than the other one that it was expected. So this is something that I would like to understand, and if please, when you evaluate my project, I would appreciate if you can send me uh, what I was doing wrong to this email address, please, because I'm really interested to understand why I'm having this problem. I have done also an additional check, which is just to let me share this on here. So I'm going to introduce this face on my test images. At the moment, I have only these two images here. I'm going to include this face on our test images and rerun the model again. Okay, I'm going to remove this part here just to leave it as it was before and rerun this in order to check that when I input this image, well, the corresponding celebrity is this one here. So the algorithm is working well, because this will be the image that has 0 distance against this celebrity image. But I don't know why I cannot reproduce the corresponding images to the expectation for this particular uh, image, although I can match it quite well on here. So that's something that please send me uh, your comments on here because I will really appreciate what's wrong. Thank you very much.